Hey, welcome everybody. I believe you can see the slide coming through now. Excellent. All right, so we in these 20 minutes, I really want to go straight to the point and save you all the conversation around what is confidential computing. You already heard a lot about it, so let's go straight and talk about how to meet PCI compliance, so payment card compliance using a solution built on Azure confidential computing. So as said, we are all now familiar with the concept of confidential computing for protecting data when it's being processed in memory. This is an important aspect though, because as you see, as part of the solution, there is no persistency of data. I'm not going to use any database. There is purely a solution that is based on tokenizing or encrypting credit card information and in a volatile memory space. It is actually, I wouldn't use persisted, but is kept in memory up to a minute just for the time of processing the token itself that is issued as part of the solution. We'll see everything in a moment. What I want to point the attention though is why are we doing this? What is the use case? What is the challenge that we've been resolving? And just short of a year ago, Microsoft and AMD have announced a strategic partnership on working on the implementation of confidential computing on AMD SAV SNP technology, which is which turned out into a product that we are offering now in the Azure portal, and we call confidential virtual machines. This is important because it can enable scenarios where we can bring existing application to a confidential cloud without any code changes. Or we can implement solutions that are based on programming languages that can benefit of the confidentiality in a virtual machine in this case, again, without any particular changes to the way you are used to code, you're used to program. So as part of this use case demonstration that I'm going to show you today, I'm going to use a plain old-fashioned, which is not that old, but actually very modern, but a .NET 6 solution. So with no code changes at all in implementing this inside a confidential virtual machine. And now to make it even more specific to the use case, PCI compliance, I want to point you to a paper that was issued by the Monetary Authority of Singapore a few months ago. So this is very recent. And what they are demanding, this authority in Singapore to all the FIs, the financial institutes, is to consider implementing solutions to protect the confidentiality and integrity of sensitive data in the public cloud. And they expressively ask to introduce protection of data at rest. We've been doing this for years and years, right? Protection of data in motion. Again, we've been doing this for so long. But now the third requirement is the very important one that has been highlighted specifically in this official paper. FIs have to implement confidential computing solutions. So now this is Singapore, but the love to confidential computing is expanding to many countries. So this is important. And it is important. This is why we've been working with customers to implement confidential computing solution to meet this requirement for protecting data in memory. And as you know, when working with financial institutes, you're very likely working with a lot of legacy applications, existing apps that are running on-prem or in the cloud, but in a non-confidential environment. And suddenly they panic and say, hey, how do we get into confidential computing? All right, let's go and analyze now a little bit of the architecture, very high level, with a few components that we put together into addressing the requirement for meeting PCI compliance when processing a payment, say an e-commerce website, and we don't want to store a confidential credit card information, but at the same time, we need to enable the payment gateway for processing this information without unveiling, without revealing the confidential information itself, so the payment information itself. So this solution works with the confidential VM that I mentioned before. I'm going to show you this in the Azure portal in a minute or two, which is based on the AMD SEV technology, which sort of enables a lift and shift scenarios in a good way, right? So where we can take existing application or we can build a brand new application using any programming language as long as I'm able to run into a virtual machine, which is pretty much everything. So when I am able to run .NET 6, a web API in any VM or container, in this case, I can do the same in confidential VM with the benefit of confidentiality that SAV-SMP offers. Now, this is part of the solution because obviously we have the computing capability there. This API will accept the credit card information in input and serialize and encrypt and transfer to an in-memory queue, and the job is done pretty much. Then is the queue responsible for dispatching these messages to the payment gateway, and these messages are kept confidential inside the AMD platform, the CVM, confidential VM platform itself. But there are a couple of other factors that we need to keep into consideration. First of all, the queue itself. It can be anything. And this is, again, the beauty of confidential VMs on AMD, that you can take RabbitMQ, or you can build your own queue mechanism in .NET. You can use any other existing platform, and even if they are not enabled for confidential computing, they can still be confidential, but the moment you're running inside a confidential VM. I'm saying confidential so many times in the same sentence, but you get my point, right? So you can build your own queue mechanism. You can use an existing application like RabbitMQ, whatever your queuing, in-memory queuing technology is. Just by running it inside a confidential VM, you obtain the confidentiality of the solution automatically as part of the platform itself. Now, the payment gateway will subscribe to messages that are in the queue. The queue will dispatch these messages as soon as possible, retaining a message up to a minute, which is plenty of time. Typically, these messages are transferred within a fraction of a second. Another component that you see on the picture is also a key vault. A key vault is your password manager, right? Is your secret manager, your keys to access external systems, to authenticate into a database, to an API, or keep secrets for encrypting data, which is what this application is doing, is encrypting information using a key that is stored in a key vault. But not any generic key vault, but a key vault which runs on a managed HSM. There is a little spelling mistake, which I'm gonna fix now. Is a key vault, not a key value. Funny how I found it now here. So this key vault is running on a managed HSM, and a hardware secure module. This enables the confidentiality also of secure release of keys. They never leave the hardware encrypted word, the confidential word. They will never be visible to the cloud provider. The keys, I mean, the encryption keys, that will never be visible to the cloud provider. You, as a customer, you bring your own keys. you benefit of a key vault solution for managing your secrets in the cloud with encryption at all the 3 stages of the data lifecycle. And you know that the cloud provider will never ever see your keys that are protected inside the HSM. All right, so let me point you to a few of these solutions on the Azure portal just to see how they looks like. We want to see a few things, right? So I'm going to go into my Azure portal and create a new virtual machine. So I'm going to create a new resource here. And this is, if you're already familiar with the Azure cloud, this is the Azure portal. This is really exactly the same process as creating any normal virtual machine. So I identify here virtual machine and then go and create the virtual machine. So this is not anything different from what you have been doing for years and years in creating VMs in Azure. So I'm going to pick my subscription, my resource group, give a name to the virtual machine, so OC3 CVM, something like that, and pick a region. For example, I'm going to go into West US, and then there are a few other things that I can choose, the image, what kind of operating system I want to run, etc., etc. Everything as you would expect to be. But what I want to point your attention to is this security type, okay? Security type is this third option. We have the standard security type, which is the best security that you can get in Azure out of the box. But then on top of that, you can have the TVM or the TPM, the trusted launch, which is a protection of your. Thank you. Yes. So this is the story basically, and with you probably seen some part of the virtual machine. Let me go very quickly in some of the code because this is really a standard web API in .NET 6 that you can create with any development tool. I'm using VS Code. So there is an API controller here, and then we go into more specifically the process of creating this token, which is unique and encrypted. So what you're going to do is obtain your connection to AKV, obtain the secret, which is released as an encryption key, and then use this encryption key to encrypt using a symmetric encryption algorithm, and then generate the token and add the token, actually the tuple that contains the token and the encrypted value to the queue. The queue will be there dispatching this message to the payment gateway. The payment gateway is using a pub sub, so publish subscribe model, where basically using this web hook that you can see is so simple, 2 lines of code. The gateway will do this web hook inside the API. The API will release the queue, so will dequeue the message and invoke a return URI that has been transferred by the payment gateway. Super simple. Probably is it would be easier if I share this code, which I will do after the event, along with a slide, along with additional materials. So then, if there are any other questions, just get back to me, and then we can clarify how this works. So, talk cheap, show me the code. Thanks, Linus, for the reminder. I've done that, and thanks very much for your attention. A few pointers to the sources online. We have a couple of minutes to take a few questions.